Hello everyone, and welcome back. In this video, we're going to explore the bit shift function blocks available in Alsmart Design. Bit shift operations are commonly used when working with binary data, communication protocols, status registers, and digital I/O. Instead of manipulating numerical values directly, these function blocks manipulate the individual bits that make up a binary number. Before looking at the function blocks, let's quickly review what a bit is. Every number stored inside a PLC is represented as a sequence of bits. For example, the decimal value 13 can be written in binary as 00001101. Each position represents one bit. Bit shifting simply moves these bits either to the left or to the right. Depending on the function used, the empty positions are either filled with zeros or wrapped around to the opposite side. Let's start with SHL, which stand for shift left. SHL moves every bit to the left by a specified number of positions. The empty positions on the right are automatically filled with zeros. For example, suppose we have the binary value 00001101. If we shift left by one bit, it becomes 0000111010. Notice that every bit moved one position to the left. The rightmost position is filled with 0. This operation is similar to multiplying an unsigned binary number by 2. In Alsmart Design, SHL has two inputs. In, the original value, .n, the number of bit positions to shift. SHL is commonly used when building communication words or positioning individual bits inside registers. Now let's look at SHR, or shift right. This function performs the opposite operation. All bits move to the right. The empty positions on the left are filled with zeros. For example, binary 00001101. Shift right by one position 00000110. Again, every bit moves one position to the right. The leftmost bit becomes 0. SHR is commonly used to extract information from communication registers or isolate specific bits. Next is ROL, which stand for rotate left. Unlike SHL, a rotation does not lose any bits. Instead, the bits that leave the left side reappear on the right side. Think of it like a circular movement. For example, binary 100100001. Rotate left by one position 00100011. Notice that the leftmost bit didn't disappear. It simply wrapped around and became the new rightmost bit. ROL is useful when working with cyclic redundancy checks, communication algorithms, and bit pattern manipulation. Now let's look at ROR, or rotate right. ROR performs the opposite operation. Bits move to the right. The bits leaving the right side immediately reappear on the left side. Again, no information is lost. Notice that the upper and lower halves have exchange positions because the rotation wraps around. ROR is often used in advanced communication protocols, encryption algorithms, and cyclic data processing. A common question is, what is the difference between shift and rotate? The answer is simple. With shift operations, bits that move outside the data word are discarded. New positions are filled with zeros. With rotate operations, no bits are discarded. Every bit remains in the data word by wrapping around to the opposite side. If preserving every bit is important, use ROL or ROR. If you're intentionally moving bits and don't mind losing the shifted bits, use SHL or SHR.